Hey everyone, continue with our transformations. We'll be looking at the first type of transformation, the translation. So how does translation work? So let's say we have the graph of y equals to fx, or actually let's put it in a more generic form, gy equals to fx. When does translation occur? It's when you have either gy equals to f bracket x plus minus k, or gy plus minus k equals to fx. Of course, we can look at it as a combined way, but we'll not go through combination for now. Of course, you can have gy plus minus k equals to f bracket x plus minus h. That will also be translation, but of course, they'll be translated in the two different axes. So on the first one is basically affecting the x-axis. On the right, or on the bottom rather, you'll be affecting the y-axis. So I'll be looking at the first axis, or rather the x-axis first. Okay, and what I'm going to do is, I'm going to write here, let's say we take, for example, we have fx plus 1. All right, we're going to see what happens if we have gy equals to fx plus 1 instead. So what I'm going to do is, I'm going to put here, let's say we have the first condition being f3 equals to g2. Essentially, this basically means that when x equals to 3, y equals to 2. All right. And then we'll slowly see out the different values from there. So what we have thus far is we know that, well, we have fx. And then I'm going to draw a small table right here. We then have, let's say, gx. And then we have fx plus 1. Okay, not really gx. This should be y. So what happens is we're going to look at the different changes from our y and to our x between the same y. So we're going to know that, well, for the first value, we know that if we have fx equals to 3, where we have x equals to 3 here, we know that gy equals to g2. All right. But what happens to our fx plus 1? We notice that our input is f3 equals to g2. So our input needs to be 3. And as you notice here, it will become x equals to 2. All right. And whatever happens is that you start to notice a sort of a trend, right? If we have, let's say, x equals to 4 here on our fx, then our corresponding x value in fx plus 1 would be x equals to 3. And you notice that it kind of makes sense, right? You notice that all your x value is now 1 less. The reason why it's now 1 less to give you the same y value is because your x, your input, now has a head start of plus 1. So now you need lesser of x because you now have a head start of plus 1 in your combined input of x plus 1. Your input is now x plus 1 instead of just x. Because of this x plus 1, this head start of plus 1, you now need 1 less of your x value to obtain the same y value. All right, so how would this look like graphically? Let's say we take a very simple example of a linear line of y equals to, let's say this is x plus 1. All right. And if we let this be fx, we know that, okay, then the graph of fx plus 1 would then be every x value minus 1. So we had over here, this was minus 1, 0. Right? And now, because we now have x plus 1, the input of minus 1, that means you have x equals to minus 2. Because our input is f minus 1 equals to 0. And now that we have x plus 1 equals to minus 1, x equals to minus 2. So all our x input will now be reduced by 1 because of the head start of the plus 1. As such, our graph would just simply be parallel to this. And this would be our y equals to fx plus 1. All right. And therefore, for the translation of our x-axis is quite simple. It is given as the opposite direction of our addition of our constant. So very simply, if let's say we transform from y equals to fx to fx plus k, it would be a translation of k units in the negative x direction. Now, it's very logical, right? Because you have this head start of k. Now that means you need k less because you already have the head start. And that's why you translate k units to the negative x direction. If instead you're going to translate or transform to x minus k, now you have a deficit, or you are pushed back by k units. As such, you need more of the x value to obtain the same y value. As such, you need k more value, hence your graph would now go on the right, which means k units in the positive x direction. Alright, so these are the transformation and basically, the translation for the x unit. In fact, if you think about the y unit, it's actually the same idea, but I'll go through that in the separate video because I have some tricks to the y translation. Alright, so let me just read this as gy equals to fx. If you transform it to x plus k, fx plus k or x minus k is the translation of k units in the negative x direction. For x minus k, it's translation in the negative, positive x direction.